Welcome to this statistical modeling recording about predictions for the linear model. So while we will typically use the linear model to do inference about model parameters and then answer a question about the data, very often you will be using linear model for prediction purposes and more from a statistical learning perspective. Okay. And in many applications, for example, in database marketing, the goal of performing statistics is to build a model to make predictions of, for example, customers, buying intention, and so on, in order to decide whether to adopt a particular business strategy. Should we open a new store in this location? Should we develop more our online retail store, etc. Okay. Or it may also require you, if you want to make an offer, make a sale, is it worth it? How much do you expect people to spend, and so on. Okay. So how would you do that in practice? Well, normally you would send to a selected set of customers the offer. Then you would collect their response, see if they've taken up the offer, how much they're willing to pay, how many products they bought, and so on. And then you can try to build the model, predict the outcome, and then if your answer is satisfying, then extend this offer to other customers. So what's the purpose of prediction? Well, is to estimate the mean of y given a set of covariates. Okay, so typically we have a sample of observation with which we build a model, but then you could have new customers for which you don't see this response and you'd like to predict it. Okay, so if you think back to our model equation, we basically set the mean, the conditional expectation, to be linear combinations of the betas, okay, times the explanatory. Sometimes also you may want to predict a new value, okay, so not what the average customer would purchase, but try to infer what could be the response for a particular individual. And based on our model, well, we say people tend to follow on average the linear equation, but then there's an error term to account for departures. Okay, not everyone buys exactly the expected amount. In either case, because the expectation of the error term is 0, our predictions for the mean or for the value of y are simply going to be the points on the fitted line of hyperplane at corresponding at the coordinates x. Okay, so in other words, you will be just replacing the unknown betas by your estimate of the betas. Okay, so y hat is basically beta naught hat plus beta 1 hat x1 up to plus beta hat p xp. So the difference is between the two scenarios, predicting individual outcomes and predicting average outcomes, is not in the mean, but rather in the variability. Okay. And why is the case? Well, if you think about it, if you're trying to predict an average, you're pulling the observations from all of the n people in the sample to predict the average. Whereas if you're looking at a particular individual, well, this individual, so the average is not going to deviate much, whereas a single person can deviate more from the model. And so the precision of the prediction for the individual value will be smaller. Okay, so in other words, there will be more variability for individuals than there will be for the mean. Okay, so if you wish to build a confidence interval for the mean, it would be smaller than the prediction interval, okay, which is for new observations. And the rationale really is if you're looking at the variability of this y hat, well, there's an extra, so when you're looking at the average, there's the error term epsilon, which you don't have for the average, because the epsilons have mean 0. But when you're looking at the variance of the terms, there's the variance of your estimates, of your estimators, beta hats, and then there's the extra variability that's just due to, that's just the sample variability for this person. Okay. So how would you do this in using software? The first thing you have to do, so of course you could obtain the fitted values, and the difference in wording. So fitted values are for the people in your sample. Okay, so you're using these people to adjust the model. The fitted values are just the y hat corresponding to the equation, but they're for the people you had already observed. When we talk about prediction, it's normally for new individuals. And so we need new individuals. So in this particular example, we're gonna cheat. Okay, so we're looking at our intention to buy example with the candies, and we have all the explanatory variables. So I don't want to create from scratch a new individual. So what I will do is just for illustration purpose, consider the first one in the database, and vary, so create copies of that person, but change their fixation time. And it's going to vary from 0 to 6. So I'm creating this new database by copying intention and then copying down by changing the value of fixation from 0 to 6 using a for loop. So now now I have these new observations. So I'm going to need to store the model output so that I can then apply, basically take the beta hats and then store them for future use. So you fit the model, and the only difference relative to the usual code is that we will have this extra line with store model info. Okay, and that will allow us to pass the information on to an additional procedure that will do the predictions. And then for this prediction, we can ask, of course, for the values, the predictions for the mean or for the new individuals, but we can also ask for confidence intervals or prediction intervals. For the mean, using LCLM and UCLM, so lower confidence limit for the mean, an upper confidence limit for the mean, and the individual prediction, that's lower confidence limit. Okay, LCL and UCL. So for a big chunk of code, let's digest it together. So PLM is a prediction for linear models. And you have this restore model info, which basically extract the information. Score is the actual line of code that says predict for new people. You have to give it a data which contains the same names. Okay, so if you have a database, it has to have the same format and the same column names for the variables. And then, as you would do in a linear model or in another SAS procedure, you basically specify the name of the output data set. So here I'm saving it in a data set called prediction in the temporary library, and I'm keeping the predicted values and the confidence limits for the mean and for the individual observations. And then I can use this to create a plot where I'm going to basically draw a line. So I'm going to predict because I had multiple copies of this person. You can see how this would vary for this particular set of covariates as we change fixation time. And I'm going to add a band to show you what are the pointwise confidence intervals for both individuals and average observations. Okay, so this is just a standard plotting procedure. And here is the result. So notice there's a couple of things going on. So this is the observations for the mean. Of course, we know from the problem, so this is a particular individual, we know that intention score is truncated to 14. So already we have not included this information in our model, but so the model doesn't know that intention is bounded between 2 and 14, and so it's predicting nonsensical output. Okay. Then there's the confidence band. So the middle band that's in dark gray is for the mean. So you see it's much narrower than the one for the individual prediction, which is in light gray. And it's not necessarily obvious for the ones for the individual because the band is too large, but you will see that the shape of the confidence intervals for the mean are not linear. Okay, the uncertainty increases as you move away from the average fixation time in your database. And this is best illustrated, of course, using a linear animation. So I invite you to look up to this. So this completes the video. Thanks for watching.